everyone. In this video I am going to talk about galvanic cell. It is a type of primary cell. Let's consider a circuit which is connected to a battery. So let's draw an circuit. You can give example like of a bulb or a voltmeter. You can connect anything if you want. So I am connecting a bulb. So let's make a circuit. As you know, current is due to flow of electrons. So electrons flow from the negative side and comes to the positive side. And the bulb, when the electricity passes through the bulb starts to glow. Okay, so let's make a galvanic cell now. In order to make a galvanic cell, we require two half cells. The left side one is known as left anode half cell and the right one is known as right cathode half cell. So we have made half cells. Let's make salt bridge also. Salt, I will talk about salt bridge in the later part of the video. So watch this video till the very end. On the left and the right side, there are two plates. You can take any plate of metallic conductor. I am taking zinc and copper plates. Zinc plate and copper plate. The left one is known as zinc plate and the right one is copper plate. And the solution is placed in the container which is known as electrolyte. Electrolyte should be the same as the plates. So as if you are taking Zn plate, the electrolyte should be ZnSO4, and if you are taking copper plate, the electrolyte should be CuSO4. Okay, the electrolyte should be same. Connect the plates together. If electrons are flowing through an anode, the reduction of cathode side should be positive. If the flow of electron is from left to right, anode should be negative and the copper should be positive. Cathode should be positive. It's the positive side and it's the negative side. Okay. So in the rod or the plate, when zinc loses the electrons, zinc breaks into Zn2 plus n plus 2 electrons electrons move from left side to right side, and zinc gets dissolved in the electrolyte. And same is for the cathode. Cathode does not give any electron, it only shifts it downwards, and the Cu gets in the electrolyte. Due to loss of electrons and gain of electron, copper plate increases size, cathode increases size, and the anode side decreases it. After the reaction is completed, we will see cathode side is slightly bigger as we have started, and at anode side the size decreases because we use electron. So now let's talk about output. First, which is used to control and to stop the charge buildup of charges. As you know, once the electron is gone from the anode to cathode, it will not return. So in order to maintain the charge, salt is used in which electrolyte is placed, which sends the electrons back to anode side, and then the process again starts. It is a type of chemical cell which converts chemical energy into electrical energy. As you have seen in your phone batteries, when you charge, electrical energy is converted into chemical energy, and when you are using it without a charger, chemical energy is then converted into electrical energy. That was a great example for which is used to stop charge galvanic cell. Now okay, 2 dash, then Cu 2 plus, we will write Cu2 plus slash Cu. It is the standard way to write. It will come to an exam like this only. So let's now talk about the EMF of cell. So let me go down and write EMF of cell potential, or EMF of cell equals to volts, and 1 volt is equals to joule by coulomb. Joule is the unit of work done or energy, and coulomb is the unit of charge. As you have already known this, sorry for telling you again. So joule is the unit of energy and coulomb is the unit of charge. Coulomb is denoted by C. So unit of volt is joule per coulomb is known as 1 joule. Now let's tell you some more things about it. Voltage of a cell Let us consider a conductor. Let me draw a conductor for rectangle shape. One end is an A and one end is B. One end is at B end 10 volts are given and at point A 7 volts are applied. Electron flow from lower density to high density. 1 coulomb of charge of electron is flowing through B towards E. So obviously A becomes positively charged and B becomes negatively charged. Change in voltage equals to 1 volt. 1 volt equals to 11 by 10 to 1.9. Current can be written as change in Q upon change in time. And 1 ampere equals to 1 coulomb upon 1 second. And 10 ampere equals